Hello GATE aspirants, welcome to part 8 of GATE Electromagnetic Theory series. Question number 1. Identical charges Q are placed at 5 vertices of a regular hexagon of side A. The magnitude of the electric field and the electrostatic potential at the center of hexagon respectively are respectively. So consider a hexagon like this, and we have 5 charges Q, Q, Q here. And we have to find potential and electric field at the center. Now potential will be easy. Potential is equal to, this will be kq by r, and here we are considering 5 charges, so in each case this distance is r only. So here it is given that it is of side A, so this will be AAA. So into 5 we have to do, so this will be 5q upon 4 pi epsilon naught into A. That will be potential. So here option C is correct, and we have to calculate electric field also. Now if there was one more charge present at this point, then electric field at the center would have been 0, but it is not there. So we can say that electric potential for these 5 charges will be equal to electric potential due to this one charge, and that is equal to 1 upon 4 pi epsilon naught q by r square. So here it will be a square. So that will be formula for electric field. So option C is correct here. Next question. A parallel plate capacitor with square plates of side 1 meter separated by 1 micrometer is filled with medium of dielectric constant 10. If the charges on the plates are 1 coulomb and minus 1 coulomb, the voltage across capacitor is. Now we know charge is equal to C into V, and C is capacitance, and capacitance is equal to K epsilon naught A by D into V. So from here V is equal to Q into D upon K epsilon naught into A. Now charge is 1 coulomb, separation between them is 1 micrometer, so that will be 10 raised to minus 6 upon value of K is given 10, epsilon naught is 8.854 into 10 to the power minus 12 into area. It is square plate of side 1 meter, so this will be 1 into 1. So from here V is equal to 11.29 kilovolt. So answer is 11.29, and answer given in the answer key is 11.25 to 11.34. Next, light is incident from a medium of refractive index n is equal to 1.5 onto vacuum. The smallest angle of incidence for which the light is not transmitting into vacuum is. So that corresponding angle will be critical angle. So sin theta c is equal to n2 by n1. So n2 is 1 and n1 is 1.5. So this is equal to, from here we can calculate theta c is equal to sin inverse of 1 upon 1.5, and that is equal to 41.81 degree. And answer given in the answer key is 41.60 degree to 4200. Next question. A monochromatic plane wave in free space with electric field amplitude 1 volt per meter is normally incident on fully reflecting mirror. So here coefficient of reflection is 1. The pressure exerted by the mirror on the mirror is. So pressure is equal to, so this will be I by C into 1 plus R. I by C into 1 plus R, but here R is 1, so this will be 2I by C, where I is intensity, and intensity is equal to half into C into epsilon naught E naught square. So from here pressure is equal to epsilon naught E naught square, which is equal to 8.854 into 10 to the power minus 12 into 1 square. So this will be 8.854 into 10 to the power minus 12 Pascal. So this is the answer. Up to 2 decimal place, so it will be 8.85, and answer given in the answer key is 8.80 to 8.90. Next question. 3 charges, 2 Coulomb, -1 Coulomb and -1 Coulomb, are placed at the vertices of an equilateral triangle of side 1 meter as shown in the figure. The component of the electric dipole moment about the marked origin along y direction is. So here we have to calculate momentum, dipole moment, which is equal to summation over QI/RI. So this will be equal to, consider this first charge which is -1 and its separation. So it is, this total distance is given, this side is 1 meter. So half of it, this will be 0.5. So this distance will be 1 meter. So this will be 1 into x cap. Now for the second one, -1 charge, and this distance will be 1.5 plus 0.5. So that is 2x cap. Then 2 Coulomb into, this will be, in along x direction it is 1.5. So this will be 1.5 x cap, and along y direction it will be this portion, this part. Now this is equilateral triangle, so this angle is 60 degree and this distance is 1. That means this opposite side will be sine of 60 degree into 1, and sine 60 is √3/2. So plus √3/2 y cap. So these components are x components and y component will be this, simply this. So this will be 2 into √3/2, which is √3, and that is equal to 1.72. And answer given in the answer key is 1.72 to 1.75. Next, an infinite solenoid carries a time varying current I is equal to AT square with A not equal to 0. The axis of the solenoid is along the z cap direction. R cap and theta cap are the usual radial and polar directions in cylindrical polar coordinates. B is equal to BR cap plus B theta cap plus BZ z cap is the magnetic field at a point outside the solenoid. Which one of the following statement is correct? Now it is a solenoid, so inside solenoid B bar is equal to, it will be constant, some constant will be there, and the solenoid is along z direction. That means it will be along z. So this will be BZ z cap, and outside this B bar will be 0. So inside this BZ component will be non-zero and R and theta component will be 0. So option D is correct. Next question. A uniform volume charge density is placed inside a conductor with resistivity 10 to the power minus 2 ohm meter. The charge density becomes 1 upon 2.718 times its original value after time. So here resistivity as a function of time, this will be rho of 0 e raised to minus sigma t by epsilon naught. So from here we can write rho naught upon rho t is equal to e raised to sigma t by epsilon naught. So this will be rho of t is rho of 0 into 1 by, this is 1 by e times. So this will be upon e, so this will be equal to e1. That means sigma t upon epsilon naught is equal to 1. So from here t is equal to sigma naught upon epsilon naught upon sigma, and epsilon naught is 8.85, and this is conductivity and resistivity is given to us, so this will be into rho. So this will be equal to 8.854 into 10 to the power minus 12 into 10 to the power minus 2. So that is 88.54 into 10 to the power minus 15 second, and that is femtoseconds. So answer is 88.54, and answer given in the answer key is 87.50 to 89.50. Next, consider a metal with free electron density. This is given 6 into 10 to the power 22 per centimeter cube. The lowest frequency electromagnetic radiation to which this metal is transparent is 1.38 into 10 to the power 16 Hertz. If this metal had free electron density of, so this is N1, this will be N2, 1.8 into 10 to the power 23 per centimeter cube. Then the lowest frequency electromagnetic radiation to which it would be transparent is. Now we know plasma frequency omega is equal to under root NE square upon epsilon naught ME, where E, epsilon naught ME are constant. So that means omega is proportional to N. That means frequency is proportional to square root of N. So F2 by F1 is equal to under root of N2 by N1, and that is 1.8 into 10 to the power 23 upon 6 into 10 to the power 22. So this will be 18 by 3. So that is root of 3. So F2 is equal to 1.38 into root of 3 into 10 to the power 16, and that is equal to 2.39 into 10 to the power 16. So answer is 2.39. Answer given in the answer key is 2.35 to 2.45. So these were all the questions from GATE 2017 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.